Hello guys, welcome back to my YouTube channel. In this video I am going to prove some interesting theorem. That is, let's say f is a function of x. So if f is differentiable at x equals a, this implies f is continuous at x equals a. So if a function is differentiable at some point, that implies that function is continuous at that point also. So this is some kind of interesting theorem. So can I say if the function is continuous at some point, that is differentiable also? That is contrapositive of this statement. Can I imply that? The answer is no, because I can prove that by an example. Let's say y is equals to mod x. What is the graph of this? This is like this, right? This is y equals x. This is y equals minus x. So this is x equals 0 point. So gradient of this thing is minus 1, gradient of this is plus 1, right? So I can say f dash 0 minus is equals to minus 1, right? So f dash plus 0 is 1. So f dash minus 0 is not equals to f dash plus 0, right? Because minus 1 is not equals to 1. Then f dash 0 is not defined, right? Either mod x is continuous, this is continuous function, right? Then I can say either mod x is continuous at x equals 0, the differentiation of mod x is not defined. So I can say either function is continuous, the function may not be differentiable, right? At some points, either if x is continuous, it may be differentiable, but there are some examples the function is either continuous, that is not differentiable. So there is no theorem for that statement, right? For the contrapositive of this thing. It may be true for some reasons, but not true for all functions. So I can say that if f is differentiable at some point, it is always continuous, but I can't say that the contrapositive of this statement is always true. That may be true for some examples, but not always true. So let's prove this theorem. Do you have any insight for this proof? Okay, I will prove. This is not a solid way, just I am using limit things. Okay, so if f is differentiable at x equals a, this is going to imply f is continuous at x equals a. So I am going to write this by limit definition. So if some function is differentiable at x equals a, I can write that limit x goes to a, fx minus fa over x minus a is equals to f dash a, right? If some function is continuous at x equals a, then I can write limit x goes to a fx is equals to fa, right? So now I'm going to take this as true, and then I'm going to imply this statement. So if f is differentiable at x equals a, then I can write that limit x goes to a fx minus fa over x minus a is equals to f dash a, right? So I'm going to use this limit x minus a fx minus fa over limit x goes to a x minus a is equals to f dash a, right? Then this is limit x goes to a fx minus fa equals f dash a times limit x goes to a x minus a, right? I multiply this by this thing, so this is limit x goes to a fx minus fa equals f dash a minus a, right? This is 0, so this whole thing is 0. So I'm going to add limits here. Limit x goes to a fx minus limit x goes to a fa equals 0. Since this is a constant, right? This is fa. So limit x goes to a fx is equals to fa. So I proved that if so I can write this because of this is continuous, right? If this is true, this is continuous. So on account of that, f is continuous at x equals a. So if f is differentiable at x equals a, this implies f is continuous at that point. So I have proved this thing, right? I hope you guys enjoyed the video. If you have some kind of problems, please comment below. Thank you for watching.